Welcome to Internet Quality Academy. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. Today also, I'm going to discuss about a very important topics about the construction. Rather, we are discussing about the construction material, that is reinforcement bar. So whenever we are performing physical test, we are find out that yield stress, find out the tensile stress. But what is yield stress? What is tensile stress? How it is determined? Today, I am going to discuss each and everything about this as per IS. So stay tuned until the end to get the full information about the tensile strength and the yield stress of reinforcement bar. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So without wasting time, let's jump into the subject, that is what is yield stress and tensile stress. To know that one, we need to go to the very basic, that is what is stress and strain, because it is related to stress and strain, and we can find out from the stress strain curve. So that is why we need to know first what is stress and what is strain. So let's start with what is strain. Strain is the measure of deformation representing the displacement between particles in the material body relative to a reference length. That means whenever an external force is applying on a body or a mass, so it will deform. Either it will compress or it will elongate it. So what is the change in the deformation or change in the length? That is called the strain. It describes how much a material or stretches or compresses in response to an applied force. So that is whenever we are applying force, either it will compress or it will elongate. So what is the elongation or what is the compression? That length is representing as strain. So strain tell us how much the material deforms or stretches as a result of the load. So it is the identification that this much the strain can be produced for this much of load. So how much load that material can take, or how much strain can be developed, or how much the load can be safely carried. So that is why it's very much important to know the strain. Now, how to measure the strain? That is a change in length divided by the origin length, that and it is expressed in a percentage. So strain is a dimensionless quantity as it represents a ratio of length. So type of strain can be elongation, that's an increase in length, or in the compression, that is shortening in the length. So let's take an example. If you apply a force to a rubber band and it stretches by 1 centimeter when its original length was 10 centimeter. So what will be the 1 centimeter divided by 10 centimeter? It is expressed as 10%. So strain is 10%. So I can understand that the strain is a measure of deformation under the applied force. Either it can be shortening, or it can be compressed, or it can be elongated, and it is expressed in percentage, and it's calculated by change in length divided by the original length. So these are the strains. So whenever force is applied in a body, the strain is developed, and we need to know the strain. As for our concern, the steel, when the external load is coming, the strain will develop inside a strain. So when strain is developing, the next is coming the stress. So strain is developing under the external load. Then what is stress? Stress is defined as the internal force per unit area that resists deformation in material when subject to an external force. So that means whenever the external force is applied on steel or any body or any material, so we know that strain is developing. But under its own property, what is happening? It is resisting that the external force. So it needs to keep its position fixed. That is why the stress is developing. So stress tells us the internal resistance to a material experiences with the under load. So under the external load, how this material will resist itself, so that is the measure of stress. So first, under the external loads, the strain is developing, and when the strain is developing, it has the property that it want to resist that strain or resist that force. And what is the measure? That is the stress. So how it is measured? The area divided by the force. It is a measure Pascal, PA, or Newton millimeter under a square. So it is a force per unit area. It's not area per force. Let me Let me clear it out, write it down, force divided by area, that is it. So that means it is force under a area. So it is measured in Pascal or in a Newton's per meter or any other pressure unit. So type of stress: tensile stress, compressive stress, and the shear stress. In reinforcement bar, the tensile stress is developing. So we need to know what is the tensile stress. Now it is showing the stress is either tensile, compression, shear, whatever. So what is the measure? It is the internal resistance to understand whenever that strain is developing under applied forces. When you pull up a steel rod, the material inside resists this pulling force, and the amount of force per unit area is called the tensile stress. Now we know that the tensile stress what is. Now we need to see in the stress strain curve, so it will be clear again. So now it is clear what is strain and what is stress. Now we need to know what is a stress strain curve. So it is a stress strain curve. This is a strain and this is the stress and this is the load. So what is happening whenever we are applying load, stress is developed, and according to the stress is also generated inside the body. So here whenever we are making a stress strain curve, the curve is coming like this. Now what is the represent? First, the point 0 to O to A, that means from 0 to A, under this point is portion is absolutely straight, where the stress proportional to strain and the material obeys Hooke's law. The value of stress at a point is called the proportion limit. That means whenever the load is applying, the strain is developing, and accordingly the stress is also developing. That is the internal resistance, and it is obeying the Hooke's law. Now what is Hooke's law? All we know that Hooke's law is the principle in physics that state that a force needed to extend or compress a spring by some distance is proportional to the distance. So whatever the force is required to extend or elongate, that is the Hooke's law. Hooke's law is applicable as long as the elastic limit. That is a very much important point. That is the elastic limit at the plastic line, and then we'll discuss later. So Hooke's law is applicable only up to the elastic limit of the material is not exceeded, meaning the material returns to its original shape after the force is removed. That means whenever force is applying, it will extend or it will compress. But whenever force is returned or force is withdrawn, it will come to its original position. That is the elastic limit, and the elastic limit this Hooke's law is obeying. So point O to 0 to A, whenever this force is there, the deformation or the stress is developing or the strain is generating, and when the load is not there, there will be no stress on it, and again it will come to the its original position. So permanent deformation will not happen. So returns on shape after the force is removed. The Hooke's law is named after Robert Hooke in 17th century, a British physician who first formulated this law. So that is why it is known as the Hooke's law. So point 0 to O to A is the portion of called the proportional limit. Now, point A to B is the portion Hooke's law is not obeyed, although the material may still be elastic. So the point B indicates the elastic limit. So after point A, it start to in the elastic limit from A to B, but it's not the Hooke's law. Now, point B to C. B to C is the portion that the metal shows a strain even without increase the stress, and the strain is not fully returned when load is removed. So in that position, if B to C, the strain is developing without showing that the stress is indicating increase the stress, and it cannot return when the load is removed. Now again, if we applying the more load, then again it will come like this. From C to D, it will not increase, then it will declining. And point C to D, yielding start at this portion, and there is a drop of stress at the point D. So what is happening whenever we're giving the applied force, the stress is developing, generating, and after C, again, it is a dropping of developing stress, and the D is the yielding point begins at C, and D is the directly after yielding begins at C. So yielding is starting at point C. The point D is termed as a lower yield point, and point C is called the upper yield point. So this is the yield point or the plastic region point. So whenever the stress is coming at the point C is the upper yield stress or the lower yield stress. Actually, we are taking this upper yield stress. So whenever coming to the D point, again, if we are increase the load, what will happen in point to D? After yielding has taken place at D, further straining takes place at this portion by increasing the stress, and the stress strain curve continues to rise up to point E. is this portion is about 100 times than the portion of O2A. That means O2A. At this point E, the bar begins to form a local neck. The point E is termed as the ultimate tensile stress. So point C is become my yield stress, and after the lower yield point, again if we are increasing the load, it will show some takes place increase the stress, and this point E called the ultimate tensile stress. And point, what is point E to F? Point E to F is the portion the load is falling off from the maximum and fracture at F takes place. The point F is termed as the fracture or breaking point of the identical stress is called breaking stress. So from this curve, what we understand again, or let me zoom in. Point A2, this is the elastic point, elastic region, this is the plastic region, and this is the fracture region. In point F is the fracture breaking strength or the fracture strength. Point E is the ultimate tensile strength, and point C is the yield stress. So whenever we are performing the tensile stress or yield strength of the reinforcement bar, please note that what this yield strength point means that yielding region, and it is the on the plastic region and the maximum force, and is the fracture. So this curve is very much important whenever we are performing stress strain curve for the reinforcement. So this thing about the stress strain curve and the yield point and the stress point or the fracture point or the breaking strength. Now another things, some material is not showing exactly the yield point. So on that case, that just like aluminum oil or low carbon steel, it is not showing the exact yield point. Then how we can determine the yield point? Here it is coming the proof stress. What is proof stress? Or the 0.25 proof, 0.2% proof stress. That is 0.2% proof stress, also known as yield strength, is the stress at which a material shows a specified amount of permanent deformation, which is typically 0.2% strain, instead of waiting for the exact yield point, which might not be easy to detect. So here it is, we are not cannot detect for the aluminum oil or the low carbon steel. So what is happened? We are taking 0.2% strain. What are the load that becomes the yield point? Engineers use 2.2% proof stress as an approximation to determine when a material begins to deform plastically. So the here the curve is coming like that. So here what is we show? There is every point is well defined, but here it is not well defined. It is shows like this a fracture stress. So what we are doing, 0.2% proof stress strain, we are making a parallel line, and when it is hits in the stress strain curve, the corresponding stress is called the yield stress, in case of whenever we are not getting the exact yield point like this. And why is this proof stress is important? Because this parameter is critical, because it makes the transition from elastic to plastic behavior. Beyond this point, the material will not return to its original shape even if the load is removed, indicating permanent deformation. It is widely used material like steel, aluminum, and other metals where an exact yield point may be difficult to measure. So these are the thing about the tensile stress and the yield stress and the proof stress and the stress strain curve. And I hope you find it useful. And if you find it useful, kindly subscribe my channel and hit the bell icon, so that whenever I upload a new video, you will get immediate notification. And I'm waiting for your valuable comment, so that from your valuable comment, everybody will be benefited. And if you want to know anything more about quality control and construction, please let me know. I will come with more content like this. And thank you once again for watching me.